acceleration is the rate of change of velocity. Now, a rate of change of something in physics means how much it changes by in 1 second, or 1 unit of time in general. I.e., how much the velocity changes by, or just changes, in 1 second. So in formula terms, that's where we define that A, the acceleration, is the change in velocity. So we use V and U for final and initial velocity, so that we're getting the change in velocity, and we divide it by how many seconds that takes to get the change in 1 second. Now, higher that formula is usually written in a slightly rearranged way, that V is equal to U plus AT. One of the advantages of that is everything's in the top line, which makes it easier to rearrange. Often you're asked about it from the point of view of a number. So, for example, an acceleration of 6 meters per second squared, we'll talk about the units in a wee second, means that the velocity changes by 6 meters per second every second. And the units, meters per second squared, come from the idea that the velocity is measured in meters per second. And then we're talking about how much the velocity changes by every second. So we've got meters per second, which is written as meters per second squared, ms to the minus 2. So let's look at a worked example. Start with a fairly simple one. A sprinter accelerates from rest to 12 meters per second in 3 seconds. Calculate her acceleration. And standard problem solving technique. What does the question tell me? What does it ask me? Notice though sometimes the information is in word form rather than always in number form. So this from rest is important because that tells us that the initial velocity is 0. The final velocity is 12. And it took a time of 3 seconds. And we're being asked to calculate acceleration. So standard problem solving technique. What we're being told, what we're being asked, and then what links them together. So at higher, the relevant formula is V equals U plus AT. Substituting in, 12 equals 0 plus A times 3. And then rearranging, well, 0 plus anything is just it. So we've got A times 3 equals 12. Just swapping both sides. And then divide both sides by 3. And we get the acceleration is 4 meters per second squared. Look at another worked example. Calculate how long a car, takes to stop. If it's travelling at 18 meters per second and has a deceleration of minus 6 meters per second squared. So we're introducing this idea of a negative acceleration as a deceleration. We will refine that a wee bit more as we go through the higher course, but for now that should ring some bells from that 5. So once again we've got some word information. The car stops, so that tells us that V is 0 meters per second, U is 18 meters per second, and A is minus 6 meters per second squared. The velocity is decreasing by 6 meters per second every second. We're being asked for the time for this to take place. Our formula for higher once again, and then substituting. Now, I could write this as plus minus 6 times t, but you'll find that easier to rearrange if you write it just as minus 6 times t. You do have to be careful with negative signs. You have to be consistent. If things are travelling the same direction, they should have the same sign and so on. You should always get positive values for time. So if you end up with a negative value of time, you want to try and find out where you've gone wrong rather than just chop it off, because that would be wrong arithmetic. Go back and find out where you got it wrong. You might have not put a minus sign in where it should have been, say with that acceleration, or maybe you've got V and U the wrong way around. So if I add 6t to both sides, though, going back to this problem, right, then we get 6 times t is 18, and then divide both sides by 6. It takes a time of 3 seconds.